So in this lesson, we're actually going to convert to polar coordinates to evaluate this double integral. So this is what we have. Notice it's dy dx form. So this is y goes from negative root 9 minus x squared to root 9 minus x squared, and this is x goes from 0 to 3. So let's draw a picture of this region that we're interested in. So what is that region? The southern boundary is y equals negative root 9 minus x squared. So let's see that. So we get the lower half of that circle for the southern portion of this region. And then the northern portion is y equals root 9 minus x squared. So that shouldn't surprise you in terms of what that's going to be. So let's go ahead and put that in there. Northern portion, y equals the square root of 9 minus x squared. So is the region the entire circle? And the answer to that is no, because x is ranging from 0 to 3. So looking at our picture, if x is ranging from 0 to 3, this is the portion that we need. So let's go ahead and highlight that if we can. So this is our region of interest. So if we're going to convert this to polar coordinates, r is going to go from 0 to 3. Do we see that circle of radius 3? R is going to go from 0 to 3. What is theta going to range from? How about negative pi over 2 to pi over 2? We don't want to say 3 pi over 2 to pi over 2. We want to keep it going in the same direction from negative pi over 2 to 0 to pi over 2. That should do it for us. So converting this to polar coordinates, what are we going to get? As we said, r goes from 0 to 3, and theta goes from negative pi over 2 to pi over 2. Now, what is x squared plus y squared? What do we know? Well, x squared plus y squared is r squared. So I can replace x squared plus y squared with r squared to the 3/2 power. And then we have to think about dy dx. Well, what do we know about that? Well, dy dx is change in a, right? But in polar coordinates, dA is r dr d theta. So therefore, dy dx is the same as r dr d theta. So then what will my final version of this be? This with r dr d theta. And then simplifying this as best we can, what do we get? Well, the thing to recognize that r squared to the 3/2 is r cubed, then multiply that by r to give me r to the 4th. So then our integral will be the integral of r to the 4th dr d theta. And then we're always going to start with our inner integral. Inner integral is r goes from 0 to 3 of r to the 4th dr, which is r to the 5th over 5 as r goes from 0 to 3, which is 3 to the 5th over 5 minus 0, which is 243 over 5. Then continuing, we're going to go to our integral. So our outer integral is theta goes from negative pi over 2 to pi over 2 of our inner integral 243 over 5 d theta, which will be 243 over 5 theta evaluated from negative pi over 2 to pi over 2, which will be 243 over 5 pi over 2 minus negative pi over 2. which gives me 243 over 5 times pi. This is approximately 152.681. Now, let's check that using some technology, see what we get. So you'll notice I'm putting it in here, x squared plus y squared to the 3/2. dA is dy dx here. X is ranging from 0 to 3, y from negative square root of 9 minus x squared to positive square root of 9 minus x squared. Let's hit submit and see what Wolfram Alpha thinks the answer is. And we are waiting. And notice they're giving us 152.681. Will it get the exact answer? Nope. Standard computation time exceeded. So it used some kind of a numerical algorithm to approximate it to 3 decimal places, but it was unable to get 243 pi over 5. It couldn't do it. Because to do that, the computer needed to think to switch to polar coordinates that made a very difficult problem relatively simple.